Welcome to Axel Academy video lectures. In this video, we are going to introduce you to the world of electricity. We will learn about some basic concept in electricity in a simple way. When we hear the word electricity, the first term which comes to our mind will be current and voltage. Current is the rate of flow of electric charges. The unit of current is amperes. It is named after Henry Mary Ampere. Then we are going to discuss about voltage. In other words, it is known as potential difference. The unit of voltage is volt. It is named after Alessandro Volta. Our next topic will cover about the resistors, how the circuit will behave when it is connected in series and in parallel. Before that, what is resistor? When the electrons move through a conductor, it will not experience much opposition. It will flow easily. But some materials are not good in conducting electricity. They have some resistance or opposition to the flow of electrons. The resistor creates resistance in the flow of current in the circuit. Heating effect of current. Let us understand the difference between current and voltage in simple way. Let's begin with basics. What is current? Flow of electrons. Now, what is an electron? To understand that, let's consider the matter. Example, a grain of sand. Break the sand into two pieces. Take the smaller piece and break it again. We can break the smaller piece again and again until we cannot break further. This smallest piece is known as an atom. It retains the property of the sand. Inside this atom, there will be a nucleus and electrons will be revolving around the nucleus. This is an atom. The center part is nucleus and the electrons around the nucleus are revolving with the nucleus as its center. The electrons will revolve in certain orbits. The number of electrons will vary for different elements. The number of electrons revolving in an orbit will vary based on the element. The first orbit will have 2 electrons. Second orbit can be filled with 8 electrons. Third orbit can be filled with 18 electrons and so on. Take a look at the video here. Now let's take copper atom as example. One electron will revolve around the nucleus in last orbit or valence orbit. When a force is applied on this electron, it will move from one atom and goes to another atom. This electron will hit the electron of neighbor's atom and that electron will go to another atom to separate the electron, and then this process is continued in the conductor and result in the flow of electrons. This flow of electrons is known as current. We know that the flow of electrons in a conductor will result in current. Then what is meant by voltage? Let's understand the difference between voltage and current by this simple example. Let's take two tanks, tank A and tank B. The tank A is kept at a certain height above the tank B. The two tanks are connected with a pipe. When tank A is filled with water, it starts to flow from tank A to tank B. Why this is happening here? You may say this is due to gravity, pressure, etc. Apart from these, height plays a major role. The height difference makes the water to flow from tank A to tank B. We can compare this setup with battery connected circuit. Tank A is higher potential N in battery and tank B is lower potential N in battery. When a tube, that is a conductor, is connected between these two ends, the flow of water or the flow of electrons is happening inside it. The height difference is taken as potential difference, that is voltage, and the flow of water is taken as flow of electrons, that is current. Voltage. In simple words, voltage is what makes electric charges move. It is a push that causes charges to move in a wire or conductor. Now, from this video, we can see that the electrons are moving from negative terminal to positive terminal through the conductor. This difference in potential energy between positive and negative terminal is known as voltage. Note that the electrons are moving from negative terminal to the positive terminal. Electric circuit. This is a simple electrical circuit which consists of a power source as battery and a load as resistor. We all know that the current is the rate of flow of electrons. the electrons will flow from negative terminal to positive terminal. But the flow of current is taken from positive terminal to negative terminal. This is because the scientist Benjamin Franklin thought current is flowing from cathode to anode. As many theories are developed by having this direction as reference, we didn't change the direction of current as it would have confused the already existing theories. So there are three major terms associated with this circuit: voltage, current, resistance. To obtain the relation between these three things, we are using Ohm's law. According to Ohm's law, the current I passing through a conductor is directly proportional to the potential difference between the ends, provided the temperature remains constant. V equal to IR. V is the voltage, I is the current, and R is the resistance of the circuit. Resistors in series. When the resistors are chained together in a single line, it is said to be in series connection. When the resistors are connected in series, the total resistance in the circuit will be equal to the sum of the individual resistance. Resistance in parallel. When one end of all the resistors are connected by a continuous wire and the other end of all the resistors are also connected to one another through a continuous wire, then the connection will be a parallel connection. The value of total resistance is given by 1 by RT equal to 1 by R1 plus 1 by R2. Heating effect of current. When the current is passed through a conductor, the conductor gets heated. This effect is known as heating effect of current. According to Joule's law of heating, the amount of heat produced in a conductor is H equal to I squared RT joule, where H is the heat, I is the current, R is the resistance, and T is the time period. In our home, we use appliances like water heater, iron box. These are the examples of applications of heating effect of current. An important application of heating effect of current is fuse. When fault occurs in the circuit, like short circuit, which is touching of two phase wires, or anyone is getting electric shock, the amount of current flowing through the circuit exceeds the normal amount. In this time, the fuse wire begins to melt due to the heat produced by the overcurrent. The melting of fuse wire results in the opening of circuit, which stops the current to flow in the circuit. Thus, it will save the appliances from getting overcurrent in case of accident. We hope this video helped you to understand the concepts better. Subscribe Axel Academy channel to get regular updates and check out our other videos too.